Hello friends, in this video we will discuss a problem based on constraints. So in the question it is given that a sphere of radius r comes in contact with wedge which is moving as shown. The point of contact is r by 5 from ground as shown in the diagram. So you can see from the diagram that this point of contact between wedge and sphere is given to be equal to r by 5. The velocity of wedge is 20 meter per second, again indicated in the diagram. Then we have to find the velocity of sphere at this instant. Okay, so let us redraw this diagram once again for the sake of our reference. So this sphere is in contact with the wedge at a certain point. Let me draw it more accurately for you people so that we can have a better understanding of this problem. I think this might solve our purpose. So let us assume this is the ground level. Now it is given that the point of contact between sphere and wedge is at a height of r by 5. So if I drop a perpendicular over here, I can say that this value is equal to r, but since this value is given the problem as r by 5, so I can say that the distance between these 2 points will be equal to 4r by 5. Since the value of this height, let me mark it in this diagram, since the value of this height is given as r by 5, so we can directly come to the conclusion that this second length will be equal to 4r by 5. Now if this is the angle theta of the incline, you can check with the help of basic properties of angle that this angle will also be equal to theta. So from here we can find the value of cos theta, that is 4r by 5 divided by r, that is 4 by 5, which gives us the value of theta to be equal to 37 degree. Okay, so now let us now start working in the frame of reference of the wedge. In frame of reference of the wedge, okay, let us again redraw this diagram. In frame of reference of wedge, so this is our sphere given the problem, and in frame of reference of wedge, we can say that the wedge will be at rest and the velocity of 20 meter per second of the wedge will appear as the relative velocity of sphere towards right. Since we are seeing the sphere from frame of reference of wedge, so we can say that the relative velocity of sphere will be 20 meter per second towards right, and the wedge is assumed to be at rest in its frame. Also, we will have a velocity v of the sphere in upward direction. Let us now take the surface of the wedge as x-axis and a direction perpendicular to the wedge as y-axis. For further solving this problem, I have assumed these two axes to be x and y axis. Now since the angle that was mentioned here is theta, again with the help of basic relation between angles, we can conclude that these two angles will be equal to theta. Now in the frame of reference of wedge, we know that the relative velocity of sphere should always be along the surface of the wedge. Since the sphere will never lose contact with the wedge, we can say that the relative sum of these two velocities, that is the sum of these two velocities, the vector sum of these two velocities has to directly point in this direction, or we can say that the value of v cos theta, the value of v cos theta has to be equal to the value of 20 sine theta. Since we want the resultant of these two vectors v vector and 20 to be along the direction of wedge or along the slope of wedge, these two perpendicular components, that is the value of v cos theta and 20 sine theta, they should cancel each other. So we can write V cos theta should be equal to 20 sine theta. Now substituting the values of cos theta, cos 37 degree and sine 37 degree, we can find the value of V to be equal to 15 meter per second, which is our desired result for this problem. Okay, thank you.